come what may. Unix workstations, consoles of your...
Welcome everyone. Just minor technical difficulties. My Ryzen after, I guess, postcode 11 was not good. Your stream data. So elf objects. For our stuff, we don't really, like for JIT in memory, we don't really need that. But for testing purposes, it would be nice if we, and I mean later in production, we of course want, like if we want ahead of time compile, if we want to pre-compile this welcome everyone, we of course need to write this. So of course you only would need a standard. There probably is a standard somewhere else, standard, open group, whatnot, you know, also so it's probably somewhere. Geez, like or the fucking man page. It's still posting. 1 minute of DDR5 training. So normally you would just reuse the header, but we want to do everything from scratch in our own language, and currently we use Lua for bootstrapping. So in Lua that is a little bit annoying. Normally you would, I mean, so theoretically you could just copy and paste this. But we can't. But that's even in Rust. Like even if you would do something in Rust or whatnot, like the first person who did some Rust elf microdependency also had to do this. The only other thing that this bit fields here are dynamically sized on integer bit defs, so mostly 32 versus 64. It is funny that they have those. Theoretically there exists already a RISC 528 specification, but like yeah, obviously then use 128 bits for those fields. Okay, what do we need? We need the most minimal thing, so we need an elf header. So there, what this are is object file formats for storing executable binaries. On DOS initially, whatever CPM was, we had COM and exe and other DOS object things, and that was ECOV or whatever Microsoft used there. Initially Linux was a out. Until like initially 1991, until GNU stuff was switched to ELF. So that is just a common agreed format of how to store executable binary things for execution and linking. That is why this is executable and link format. So we hopefully need very little. So what we need for our first function, welcome everyone, is, so we're probably up now. Now we are up, amazing. Let's see how long this will be stable this time. There's another tref, which would make kind of the most sense, like if memory, like the self-refresh stuff, and like it's stable in production, but not suspend resume. If this is like the only the sad thing is I need to test this now, because like actually I wanted to say like, hey, it's freaking stable because it had an uptime of 14 days or so. It was the last boot here on whatever. Is it 17 days plus or whatnot? Is that what that means here? Yeah, so much. It's probably stable. Crashes. Yeah. Anyway, so RISC we have here probably still the test file here with one function. So we can cheat. So only would need to read the specification, but that is of course resistors are many symbols. I had hoped, can we, no, we don't have this in the history because we crash build. Let's strip this and hope we don't like, because all I want, I hope we only need I hope we only need one. I mean, those sizes here are 0 anyway. So what we need is we need a header. We need a file that says I'm an elf file. We need the executable data. Here are theoretically relocations. Which I would hope in this relocations is like when this is dynamically loaded to any random, also for security, virtual address, that all the right symbol and symbols of vars and jump targets are modified to the actual virtual address. I hope for this thing that doesn't have any memory, like for our first test function, I hope we need nothing. Of course, later we would need to write all the stuff, which is not rocket science. It's just like, this is only like, it's this kind of instruction, and the symbol then so that the dynamic linker is using this to determine what kind of bit format to write there in memory. And good afternoon, welcome everyone. So let's rebuild this cross bin GCC. So let's strip this. Wait, strip is that optimize one test, also compile test C. Okay, that still has, I mean, if we are unlucky, we would need this file attributes of RISC-V urge. I don't know what the GNU linker does when we so the elf header is this here. That's just like F64, all the RISC stuff. Here are the symbols. This here is the section headers. I would hope like are this zero sized and size like there is. So the GNU assembler always writes them even if there is nothing in. I would hope. Some of this is also really shitty to read. I wonder if it will link with. So where does it name? Why is this like 2-line? But okay. Here's the size. So that's size. Text is size 4. I mean super tiny. Oh, this is probably did right. It did probably write compressed instructions again. Doesn't matter, but is G, does G means compressed text? Because we had 2 instructions in there, it should be, yeah, now it's 8. Yeah. Cannot disassemble that again. So I only need to redo this because I had to reboot Smith. Yeah. So I mean, theoretically, we only need this 2 bytes of payload. All the rest is we need to write a lot of maintenance data for that. Okay. Test if writing. So basically, so later this needs much more maintenance. Right now we've hard coded this of just like, okay, we need symbols. So let's give it, what was our name test? Let's create a, so S stream, that's a little bit, okay, T for text. And so that's a little bit of a hack, of course. And just as I want text and let text and symbols to words and put here symbol. Okay, it should work like this, right? At offset 0. Of course, later we need more automatic maintenance things. So for quick test, we hard code some things. Later we need some structure. Actually, let's do that already. Let's also TS and elf. So for now, we will use a duct tape Lua table later in our code, just because Lua doesn't have struct, which sucks a bit, which yes, more dynamic language. But that is also why I want a better Lua, basically there a C minus of reasonable, more readable C with, should we call it B4? Still need usually not too much beard work, right? So write elf. So the only things in Z writing in Lua, everything is possible. It's just a little bit annoying, right? So write fn function, like basically maybe even a stream. or F for file. It's like, yeah, now we got a little bit confused with our naming, but it is what it is. Then elf, the elf header. Actually, let's maybe call it elf header. And then what was let f? I hope it worked like that. Didn't do lure in. Actually, we could even have it have as an arc if arcs. I hope it was arcs, right? If arcs 1, then later much more testing out. File, yes, error checking. I wonder, did it need write things? Is this an API? I've done not this. I've not done this in ages. Lua IO. Must be something like this, right? Please tell me that is IO, right? Yeah, that's it. Okay. As to be expected. Although I hope it doesn't need B for binary. Okay, we are not using this on Windows. Yeah, actually, shout out to someone. Very rarely someone buys me coffee. You know what? We didn't open that yet in. All right, didn't post this yet. Someone today or so actually donated some byte. More people need to do that more often because not many. What should I drink if nobody donates me a drink? So, write elf. What was our calling convention? Elf header. By the way, does it need? Maybe refers to symbols and then text. Of course, later more. Later we will probably do some class of, and like similar to LVM, just in tiny. Let's hope that is enough. So writing this will be annoying in Lua, but that is the pain. I rather have non-crashing stuff here in readable code, right? Because, so for first, we can't, normally you would define the struct in any reasonable language, in any not dynamically typed language, but it is what it is. So we need to custom write those things. I suggest we do here some helper things because, like, unfortunately, we need to create strings here now. That is memory safe and stuff, but annoying. I would say helper functions. Let fn. We need here like stuff like u8. So ident magic through followed by elf 7f elf. Okay, fair enough. That we can actually write reasonable, so that would be the only question. Has lure? Oh, I don't do this that often. It's 7f elf, right? That's actually not too bad to elf. Yeah, probably like this. Later we do this more amazing. Byte is set to either 1 or 2 signed format respectively. Okay, so I guess we for now do here some what do we need? E-ident, what is that even? E-ident, oh, this is, okay, we need also bytes. We could, so the way to write this in Lua or other dynamic languages would be right. We need to like if we have numeric data to write, we would need string char. Of course, we could locally cache that and stuff. I think it was. Oh wait, char. I think it was char. But I suggest we make our life slightly easier and create here. I mean, should we use U8? Yeah, I guess. I mean, so later we don't need this. Like we need later in our own language. But that comes a little bit later. Like for now, let's use such things. How many? We probably should copy and paste that. If we have a structure, actually, maybe I should have. How many? I think it was 30. 40 end of health header size. Example hex dump. Yeah, so those things you would set to size off here, but again, it's not ideal, but it is what it is. What is this? The whole ident thing is so 1 4 class. Yeah. So generates this U8 thing for 2-byte things, and then U8 let's locally cache what did I say? Char, right? Let's locally cache char for performance. Who calls this I? So what is it? Local Endianness, right? Is this whole stuff then? Probably has this Endianness here, right? A little error here. Endianness vector affects interpretation of multi-byte. Yeah, starting with offset 10 is of course. That was class data. Later we should have this in this elf header, but this is and struct. This is basically, that's only bootstrapping, right? I hope later this year that we have this in our own language then, but first we need code gen working. What was that, little endian, or which one was? So we are currently unfortunately little endian. Set to 1 or 2 to signify little, so probably 1 for so normally you would want this in probably the man page had that in EF if you wanted to use the same name. Probably we would want to use the same names, but what was that here? 64-bit. So we need definitely U32. So yeah, they are a little Endianness dependent if we write it like this, or even in any other language, but it is what it is. Is there any other way to do this more efficiently? Probably not, huh? So little endian means should be that here. I believe Lua error is probably out if this is, I think it's range checking those. It's AMD GPU Crest. Yeah, it's my fault though that I didn't. I should have AMD GPU things here. Which one is it? By the way, is it Chief X Hub? I didn't watch Doxes, but it's not even Steam Deck. It's all freaking. It's not even Steam Deck. It's all AMD GPU, which is hilarious. I tested this on the Ryzen. I specifically last December live streamed on 13950X with 6700 XT. Which program does it even? Oh, this is in process Hyperland. It's hilarious. But I don't want to reboot now. Like usually when it crashes once, it doesn't happen again. Did I had this here, AMD? Yeah, I need to test this. I should have long done that. The thing is, after live stream, I have usually other things to continue. That is why. Usually, usually I forget. Why do people always call me? Good, so then did we now lose our last typing? Or that would be really annoying. Oh fuck. Seriously? But here it is. Why does Emacs not, or did I click that away too much? Yeah, AMD GPU is unfortunately my most unstable experience. This is sad that I need to say that. I mean, it's stable except on a live stream. Like, I mean, okay, it is stable except live streaming, but like, I mean, the problem is maybe, I don't know, nobody of the AMD developers live streams. So it's sad. Does this make sense? Let's test that. Maybe we should have that. Wait, can it not position down, or how is it positioning down, or do you need to click something? Or do you probably need to change the layout mode, huh? Okay, cool. 306. FN, right elf, yeah, here. The code, text code, and symbols. Attempted to index global args. Do I not do, or maybe it's, how do I pass this down? Maybe. Test. Oh. Attempted to index global. Oh yeah, right. I mean, is it even? Let f equals arg 1. We only need to check it once. Total high performance optimization. Then Bad argument to write file expected got string f IO open f file expected got string. F elf is writing Lua that difficult. That is file argument 1, 2. Ah, here. Okay, I'm stupid. Oh no, right here, because I don't call this correctly. Guess should start streaming on an old 46 MB stability. You mean you? You mean you guess I should, or you guess you should start streaming on old? RX. You mean, or you have a I historically didn't really have the problem. I mean, maybe it is like RDNA bug. I don't actually, now that you say this, well, in the future, I never had actually this issue with old graphic cards and Xorg. Yeah. But oops. Okay, test O. We start to get some data. 7F, 4F stuff, 02, 01, amazing. Just how we want this. Then, okay, let's write more fields. How much? 160. It is what it is. We want to write everything from scratch. That's what we get for that. Means I wonder what the assembler does if it doesn't get all those fields at all that are empty here. What precisely is this here even? RxVT6IP2P. Or is it like some safety linking thing? Oh, strange stuff. Okay. Let's log out that it suspends to memory while we work on this version 1, set to 1, so 6. I need this somehow more efficient. That would be more efficient. Look at that. What we could do is, I mean, not the indent, but the other things we could already more stuff should be more stuff should support rectangular selection. Okay, let's at least so where we version. Oh wait, then we don't have the size. That's also not ideal. Wait, version is 32 freaking bit. Type is also type machine. Why is this byte? Wait, why? Because it's part of the indent. That's a little bit annoying. That is a little bit annoying. That's all indent. How large more indent is 616, right? That's a little bit annoying. Why was it specified so stupidly? What did I just say how much it is? 16? Yeah, that is why I don't want to use Lua. I've done similar things in the past, but as you see, it's not totally amazing. What even was is here it's then 16. Writing 16 bits a stupid way. That really hurts you all, but okay. Version 1 OS ABI is Linux. So version 1. I mean, you know what? Let's do this a little bit more clever. We could even. It's not completely garbage. What did they call that? Class data. Oh wait, we had there 2 for 64. We could even, do we have here little data of none? Maybe we at least already it's not amazing, but we could. It's of totally not cool, but class 2 better than nothing. Where is this Earth? To complement. Oh, this is to complement LSP. Invalid version current. Okay, I think version we just do one. And then here we do elf header. Magic. Time to implement structs. Yeah, first we need code gen. First we need code gen before we can do structs, because we are still bootstrapping with Lua. Or actually, maybe we don't comment it again. It's just like it's. Oops. Source data. Cut one and use your copy and paste buffer. Then version. Okay, version. Was it E? Wait, that's another version. OS ABI. Linux was something, whatever. Let's. Okay, we need to look this up. BSD. Oh. Then actually Linux was here, maybe 3. I mean it's okay. ABI version things. Dynamic linker things. Linux kernel has notified. In case offset things are glibc. Yes, treats this field as dynamic linker list of API version. Padding reserved things 7. Someone using a graphical editor, not that much actually slower than Vim. How did this happen? And where do we have version? OS ABI. And ABI version. Padding, we can simply. Why does this jump so much when I. So it wasn't me, it's just pressed enter, it did that. We could simply manually fill here like 2, 3, 4, 5, 6, 7. You couldn't even do this in C. So much to Lua sucks all over. Like no, like hey, you couldn't even do that in C. At least not with string with implicit string lengths. But this probably should work like this. 1, 2, 3, 4, 5, 6, 7. Does this all? I mean, if the other stuff we will see in a second if this stuff isn't in. Header. Okay, now this stuff here. Address size offset. So they are obviously following types are n bits of stuff, fn and byte, unsigned SHA. All the other things are bit sized. For now, I guess we hardcode this. Except which one was the other one? Wasn't there? Why else if byte unsigned SHA? Oh wait, sorry, this here are I was in the wrong thing. So 16. Why is here we are 1632? Or did I delete this already because I thought we had that? Because I thought this type of machine was already a thing. Project we are writing. I really need, but people really want the setup. We are writing a new. We want to write everything from. We want to. We have a great reset project of zeroing our technical debt and only own our own bugs. But we only started this. Like otherwise, we do to T2 Linux here. But that's mostly feature complete and mostly amazing. And now we want a tiny LLVM and things. So let's take these all also from basically here. we probably call them then that. I mean that this deletes. I mean, use this list Emacs stuff. It will be amazing, except when it isn't. Maybe. I mean, actually, Emacs could do rectangular delete. Like, why does this delete over a new line? Who thought that is a good idea? Next, we need to write an editor. Once we bootstrapped, like, who the heck? Need to select this here like Windows user just because the editor sucks. That is probably what they meant with use an IDE and you will be 10 times slower. That's probably why you always wanna. Did you use atom and code? Oh, do I really slip you 1 pixel or must be, huh? Okay, we need the types here, so this is a little bit okay. This is also wrong. I have to say I have Emacs better in memory. This is here a little bit more annoying than I would have hoped for. So 16, and then let's do this once for E-type, and then so we have done that. Amazing. It's probably typo free, is it? This is function called. I have few typos in here. Nobody noticed. I have the feeling with Vim we all notice typos better for some reason. Okay, that we have done. This we need to do. So can we do this the most efficient? Yeah, thankfully we don't need to write so many data structures, hopefully, famous last words. That is, of course, a little bit too annoying. Let's hope we only need, oops. Yeah, it is what, I mean, yeah, it's just a little bit repetitive and formatting this nicely. Yeah. It certainly doesn't help that we don't have a language mode. Like, why is this always so? Do I really move here 1 pixel? No, why? This is impossible. What is this Lisp code? Okay, I think Emacs is not for me. It's a pity the Emacs people have abandoned their stuff. So 16, 32 address. Actually, we could do that n, actually, un. Doesn't help us the most, but at least it reminds us this is dynamically sized. Size. These are really UN16? Looks like it, huh? Let's. Okay, 64 is a little bit long. Wait, somehow I have here also a bug. No, I forgot to. I mean, I'm sorry to. Okay, that was my fault, but I have to say, I mean, I didn't use Emacs as you've seen the. I mean, I mostly. But I have to say, otherwise, it is. I think I was more efficient than. We have a problem now that we have, but that doesn't, or actually, let's hope we don't need, so that's a little bit of a problem here. One needs to know, also, by the way, we could theoretically write it like this. That should be identical. Just to have this similarly formatted. We have the problem that our, we have like 56 bits or so in our double precision. We can also write 12 objects if we invent our own 12 objects. Better you all come up with a good name for our language. Yeah, we need our own native stuff quickly because, as you see, writing that in Lua ain't the most pretty. 40, 48. And that's of course also the problem with Lua, and I mean theoretically why they introduced dual integer, which I hate. Because you can't have true 64-bit things. That's at times a little bit near. So 56. Let's hope we don't need any such high numbers for some reason. Okay, I did this here already, so you know what, I think it's faster to type it. Actually, what we could do, if we don't... It is a little bit error prone though. Yeah, basically we need a language LSP for our language. We probably should protect them all, or because we didn't fill them all yet. So we could do all 0. So if it's not defined, then number 07L. That's true. Elf header and all right, we don't redefine that here. 3 elf header indent here. UN. Alright, I didn't do this yet. Let's just... So later we need this dynamically. But for now, let's just... Okay. It probably is not yet correct. Would be surprised if that worked just on the first try. Not... Oh, this doesn't have... Oh, this, I did this here wrong. 0... Okay, it complains there are no sections in this file. That is... But it doesn't totally blow up. To complement elf, Unix, GNU stuff. Amazing. Pretty many zeros, what that's to expected. Ah, we saved this already. Let's ship it. We need to fill out some more things. We could even do that here. So machine version. Machine is risk 5. So do we have here ABI, ident ABI version. Padding reserve E ident pad. Do we have pad EI? Reserved padding bytes currently unused should be filled. Do we write this? That should be 16. Good question. This is 4, 5, 6, 7, 8, 9. Plus 7, right? Maybe. Okay, we also have here type though. Where do we have... Did I delete? Ah, probably deleted this E type because I thought we had the type already. Too many types. Parcel services ringing to everyone or whatever. Everyone interrupts me here. Why? So type relocatable executable shared object. Good question. What is? So probably we suspended, right? Okay, let's test wake up stability. No. Ethernet probably takes a while to wake up. So, machine, what did I relocate to both file? Oh, okay, that object is relocated with file 1, etrl, etrl. What did we had? Type. Next, RISC-V, F3. I mean, do they log this nicely? No. I mean, they print the name. Yeah, RISC-V. People who maybe there's a reason why so few use Emacs. RISC-V, what do I, okay, machine here. Version probably 0. Version 1. Okay, version 1. Entry point 0, start program 0. Okay, section start of. So that is bytes into the file. That's later when we write that. Flex for. Okay, we need some flex, unfortunately. Okay, it's probably double FP. Did they say 4? RISC-V flex. Later this needs to be dynamically set by features used. Then more sizes, probably mostly 0, even in OR. It has section header, number, okay, section header, string table index. Yeah, so writing these headers will be a little bit annoying. Okay, that's in the right places. Look at that. Now it's RISC-V version 1. Double float ABI. Good. Then unfortunately the section. So the text section here, as you see here, is so the one problem a little bit is apparently writing this. That apparently to write this, if you need to specify the start, size of this header, 64. Size of this header. Okay, we hardcode this for now. Which one is that? Size of this header after flex. Size of section headers. Number of section headers. Section header, ph program, size of program headers, number of here is one not, probably mid typo. size. Did I say that's probably error prone? That's better. Number of program headers. Okay, so unfortunately we need to write section headers. So normally all we need to do, I mean, we could already dump, so it's basically the header. Actually we could, or should actually a write header function. I mean, what we could do is, or what, so either you, because there is a start of section things, FL header, you could write it, I mean, if you have a seekable file, which you usually will have, you could write it, seek to that, and like track all the starts of sections and seek back, and even in any language like Lua. Write elf header header. Probably still does what it should. No, fn. Amazing. Then, and that's also why I want to fast forward with our language, right? I no longer want, I mean, I improved our Lua fork now, but I want to move on and have like for the future, for all humankind, think about the children and stuff. One last amazing language. Isn't this sucking as well? That's certainly a good reminder of what do we really need, like basically finding priorities and how we want to have it most readable. And so on. So then we could write here, so the code section should be trivial. I would hope. Read elf doesn't. So symbol, I mean, symbol tab is a little bit nass. So why does it have relocations? Section headers. So now we would need to write section header string table index. Why do they? Does it mean like here, like simply we have number of section headers 12, section headers 12, string table index 11. Probably need to open some spec thing. Why does where is attribute section, file section? Ironically, it would probably be easier to dump a whole minimal file without, like, I wanted to write the .o file to link it together with GNU LD, but all the section. I mean, the only good thing is like once you typed all this stupid stuff down here in a high-level language, then stuff becomes much faster moving and just working. The question is, was here offset to a string, sort of sh name in this sh string tab section that represents the name of the section? Okay, that's what the header string section is about. Section header sh name, section header type, flex area, which literal section area for sections that are loaded. What do we need here more? Do they have here? So what do we need? Dissected file uname. What do they have here? Arm executable work. through. Simple on hello world. Sections, content of the executable, technical details, linking. Are technical details for linking ignored for execution? So yeah, for if you link, you need more information. If you run it, it's mapped into memory and relocated. So elf header, we have done that. Here's this beauty. Program header table, program header table, segment p-tab. Here is the text, right? Like where do we have code? Sections of code data and like hello world and stuff. It's a nice graphic, I have to say. So there is also this section names section. I mean, so given that is Lua, basically, if we write this in Lua, actually, we could potentially make, so here's offset 0. What do we have here? 0 dot sh section header. How precisely does that? Maybe we should actually read a bloody standard. So okay, here's, why is this starting with 0? So maybe we should read a bloody standard. That probably, I mean, I googled earlier, just I didn't instantly find it. Yeah, maybe it's here, some university. The problem, 60 pages. Why do I use Wikipedia? Usually, like quickly YOLOing this stuff is faster than what obviously. The real quality thing is using that. Okay, we've done that. Hey, we are already 12 pages into the standard stuff we have done. Special section indexes, things, sections, an object, section header table. Let one locate all the file section. Section header table is an array of ELF32 structures as described below. Section header table index subscript into the array. Header E of member gives bytes offset from the beginning of the file to the section table. Tells how many entries contains. Section types, proc bits. That's why I hate that copy and paste is always in there. Oh, no, we copy and pasted something halfway decently. Hi user. We probably don't. Marks the section header as inactive, doesn't have an associated section other. Probably need something like that. Oh, look at that, that even worked. Yeah, the first infrastructure is always the most annoying until you have some good structure, especially if we use a dynamically typed language like Lua. That's not totally ideal, but as you see, doable. Good. We section headers. So basically we would need to write those headers. Flags. Oh, that's so annoying. I mean, it's kind of easier to just jit the code into memory and execute it. What I suggest we do is, so where do we, special sections, type, so where is it required? Do we have somewhere? Here is, okay, index, it needs to be none. Here is this index, by the way. String table section holds null terminated character sequences, commonly called strings. The object file uses these strings to represent symbols and section names. One references a string as an index into the string table section. The first byte, which is index 0, is defined to hold the null character. This is why I just was wondering why it started with null, but reasons. Likewise, a string table's last byte is defined to hold a null character. Oh, okay. And during null termination for all strings. String whose index is 0. Either no name or null name, depending on the context. An empty string table section is permitted. A section header's sh size member would contain 0. Section header's sh name holds an index into the section header. Okay, so basically let's write some strings. So what do we need? I mean, either we create this dynamically by writing. So the real, well, that would be the real thing would be to string table of, what do we call it here? sh string section header string index. Text data string tab. Here is a symbol table contains 13. Okay, it's probably 0, right? Size 0. But this is symbol tab is also another. That symbol tab is not string. Maybe it doesn't even dump string. I guess what we want to do is string tab empty. I mean, we could already write it. Basically, fn write string tab f. Probably need more. No, I mean, actually, we do not need more. Basically, all we need to write a string tab is basically f write. I also would say as soon as you have some structure, it becomes immediately more fun. So they say it needs to start like what does it call this? Basically standard demands dictates the first byte, likewise string byte a empty section header holds. Where was the first byte? So we how shitty can copy and paste be? Seriously? Are you who programs this? What does it call it? Is that right? I mean, okay, they only dictate that able name dot variable able 0 0 xx 0 able mystery what because they somehow say then last needs to be null for some reason, right? 0 null, one name dot able. Why do they have here 11? That is funny. Why do they use, oops, what happened now? Did it crash? What have I done now? Was this a mouse gesture of back? Holy shit, didn't even know that existed. Do they write here that a string may appear more than once, referring to substrings may exist? Oh, that is what they want to demonstrate here. They want to demonstrate you can use substrings. That is crazy. I mean, text compression things. Okay. Okay, good to know. But only so, I mean, why do they have XX here though? Or do they want to say okay, with that they want to show unreferenced. I mean, why would you dump random data they of unreferenced strings may also are allowed? Like, why the heck, why? Okay, we would never write it like this. Basically, also we wouldn't. Basically, it only mandates there needs to be a trailing zero. Fair enough, but given so we don't need another trailing length. Basically, for I. S or V or K or I, it's not K, I S for string in I pairs string. Let's first, we will not use substrings if we later need this for performance reasons. But yeah. Simply write this, so that's basically all the stuff, and then F write. So the strings will be the normal regular visible strings. So F write S 0 terminated. Although I guess does, I think Lua does. Can be Lua equals I standard out, right? Should that be, why does this not T, right file, what? Why does it, return, that's not, huh? Why does this still output file? Okay, so this can take multiple strings. It's slightly more performant if we don't, if we have halfway decently long strings. Here. Just performance optimization. Let's write a null string here. That's slightly faster than concatenating that. That is basically forcing a 0 byte, write the string and 0 terminated. Okay, we obviously, okay, so to do obviously write string tab F string tab, then string tab. Is this somehow, is this directly dumped without further? Really not. Symbol table. Maybe that's straight dumped out there. I don't know. Is it really? I mean, probably a special section without. Okay, so that is we need section headers. It's quite some tables to write you all. Quite some maintenance data for just some lousy 2 words of instruction. I mean, you usually have more than, but number of, why is section headers? Okay, section header. String table index 11, or is this saying the string table is 11? Section header string tab. Okay, this is okay. This is how this works. This is telling it in the section headers 11. Yeah, so later in a real problem you would have classes. So much to people who was like object-oriented programming sucks. Like, no, of course not. Then you would they would automatically enumerate if we create section headers, and they would increment some counter. So somehow here's some null section for reasons. Maybe mandated by the standard of all things 0 for whatever, then text data. Data is even 0, so I mean, I wonder if we need, I mean, we could generate an empty data section, no problem. So all where's the size? All of those here are nearly empty except the bloody comment. I would hope we don't need that though, but I mean, we can always synthesize some random stuff. Here's symbol table. Symbol table. Okay, symbols we had quite some for some. Okay, that's the symbol table. I mean, if we want to have a complete suite, we also need to implement reading those. Yeah, it's quite some stuff that is always, why do few do this? But hey, the LVM people also did this from stuff. So yeah, it gets getting a little bit, you think you quickly dump some things and then what do we minimally need? We need symbol and executable. Should we test if maybe we need relocation infos? Is there some elf? Wonder, okay, so it makes no sense to delete. I was wondering, can we delete this? Okay, let's dump some. Okay, let's start some strings. Let's yeah, we need to implement it anyway. So let's just start here with some test strings. Later they will fill dynamically, but let's just for the sake of testing. Okay, for that we need the header, section headers, all right. Why do we have, okay, section headers, symbol table we created. Relocation needs this later. Section header. Okay, index 0 is reserved and undefined. The section header table contains an entry for index 0. That is if the ESHNum member header says it has 6 entries in the section. They have indexes 0 to 5. The content of the initial entry are specified later. Section header. Name type, flag things. Probably offset is from the far right. The first byte of the section. Yeah, in C we could just sources no, but okay, let's basically copy this. Right. Okay, we somehow they're all 32 always, or nothing dynamically sized. So they're mostly 32. Maybe I do one. Actually, copying this wasn't the most clever thing. Actually that is section header, sh name or 0. Language server would be nice for our language. Link info link info oops. I don't know what the GNU people drank while they wrote this editor. So name type, flags address, it's probably far right. Section header. Section type, we did that right. I copied that already. So that is index 0. No things. Okay, probably too repetitive editing stuff for people to watch, I guess. Wait, why do I have that for that? Not sure I did this. Then we would need to write section headers, so they just come one after one, right? Elf header, program header, table, code scenes, simple header, technical details, linking, section linking, program, section header, zeros, tabs. This is also like, okay, this is why this first needs to be null string, then null names index to the null string thing. So basically we need a null. Okay, so they need to come all after another, and so that's offset. Did you somewhere say? I'm not sure why they say here B, or is it because it's here? Maybe here, probably from. I guess it shouldn't matter where they are. For testing purposes, we could, let's write here string tab. Did we test this in solver shape form? I want to see this slightly more. Yeah, foobar. So that works as expected. That's not rocket science. Writing some zero surround. I mean, basically, that's for all the things not more amazing in Lua. At least that's more amazing in Lua. Writing zero terminated strings. That works, but section header. So basically, let's test that too. Write elf section header. Did I call this sec header? Section header. Section. I didn't short it that much, did I? So the beauty is we can just pass an empty table with this duck typed elf writing. And that gives us 1, 2, 3, 4, 5, 6, 7. Wait, Kansas? Oh, it must be wherever. How large is a section header? We also need the string table. So the difficulty is now we need the offsets here. Section header. So basically, if we write a string tab, we need some infrastructure to, I guess, kind of for us, if it doesn't matter for us, it kind of is the easiest to write what we want. Basically, and keep track of the sections. Basically, at least that's the easiest for us. I would hope that would work, right? So for the reader, it should basically not matter. For the reader, it opens a file, reads the elf header, reads the section header. So okay, string tab, we tested this. Basically, the easiest would be to write the sections, for example, even the code. Let sections. So later move this into some class. For now, just one for testing. Because then, like, basically putting, for example, the text section, we would have, what was TOS was symbols. Okay, so we have one symbol here currently. Basically create those entries. Even the string tab. Yeah, basically for each string we need, like add to string tab. We could even test that. Like basically elf string, and I think for now we could use here. The best would be to pass this. We have string tab But to keep it easy, string s, basically string tab just adds this. We could do a search, but that would be ON. If the string's already in there, or even a substring search, but wait, how did this work? What did this? What did the standard mandate? String table. So basically, that sucks. So basically, we would need. Okay, slightly different of what I. So basically, plus nz sets. So given, so that's off by one, like if we implement this, okay, so we should later implement, I mean, given that it's easy then to implement optimizations of like just search, substring search of the whole thing. I mean, besides it's still ON performance. The thing is, we need a stable data layout, like if we wanted to, I mean, we would, it's I would say it's mostly not worth optimal, obviously not in the beginning. Because we need to keep them in order and stuff, right? We cannot reorder them. We need, like, if we write stuff, we need to know where the string index is. So for now, string tab length plus size of the string, actually +1 because 0 terminated. And so the next string, we also need learning and inspiration is big online and streaming. Happy to hear that. We actually need the previous length. So for temporary things, I just use underscore. Yes, I know that triggers some people. String tab length, like shadow that increments this. So that is 0. I mean, either we start with Either we start with 1 because we implicitly write a, right? You know why they probably have substrings here, because like in normal programs, especially C++, there are so many things like similar names, obviously, but yeah. I mean, we could even add here a first entry. Look at this. If like maybe we make it explicit, like then we have an empty string in here in this array. That would be the I'm always do I want nice. Then we need to change our string stuff writing. Then we don't need an explicit. Then we don't need a right string type. First must be null. So it's basically the 0 terminate string. Then this is more less code, more data driven string table. Then so that it's adding that should later optimize that to do optimize. Yeah. YOLO. Add that, save that. So because the beginning is the previous, right? Increment is and then so the first is 1, and then we increment this with +1 for 0 terminated. Yeah. Because so theoretically, like basically, what do we need? String tab. Okay, so basically we would need to write. I mean, we have a high-level language, so caching random things is way easier. I mean, writing this structs is more annoying, but not difficult. All the high-level stuff should be way easier in Lua, and usually orders of 10 times code reduction of maintenance, work, and housekeeping, and garbage collected things. So here we would need to write sections like text and data and BSS and stuff that would accumulate those strings in the string table. Then when we are done, the irony, okay, we have here sections, right? Do we have sections? Okay, this should fill the section table. Do we have code for that already? Apparently not. Right, section header, half header, section header. The only thing is the section string. We need this string tab name here. Number of section of is 11. Section header string tab. Okay, we have section header string tab and general string tab. That's our symbol names. Symtab. Where is symtab? Here's symtab. What is the difference between? Why do we have a string tab and a section header? There would be the section. Maybe that is non-section like normals. Okay, so symbols is program symbols. That is probably other strings in section things, and the others only section header string tab. But that's maybe that is also stuff like what else could it be? Symtab. This text here. Not amused. So apparently we need 2. That's unfortunate. You know what? We can use a special property of Lua that arrays. So Lua has a special optimization for arrays. At least the old Lua, I don't know if they got rid of this. Length equals 1. So that's in the hash part and that's in the array part. It should work like this, something of that sort, because we need 2, unfortunately. String tab and section header. The question is, does string table, or any string table needs to be 0? Probably, huh? Because then we have here, okay, let's, so then we need to supply here string tab and stuff, and then string tab length. Did I call this length? Yes. String tab length plus a string. Probably should test this, huh? Actually, I hope I can quickly link that today. So much to quickly link that. Call elf. Okay, fufu. Naja, okay. That's probably work. Yeah, okay, that works because we need to, here we need to put in the index in. I mean, we could, let's try to write a section header for, so how was it? Write section header. So the first had to be null for some reason. No type things. I hope we don't need file. We need text though. 2. Section, local default index. Index. Quite some maintenance information just to surprise. Yeah, we need quite some things. Do we even have enough people watching for this? Yeah, we need some better code structures, like some real freaking classes, like just yoling this stuff together is a little bit, nah, it's optimized typo. Basically what we need to do is we, for example here, we would need to section header strings, like the section headers are indexed into the section header string table, right? I guess we should read the standard. Special sections, section header, name, index, undefined, here was. This member specifies the name, value is an index into the section header string table. So yeah, here would already be the first, what else do we need? Address, offset, thing size. I mean, if we leave everything 0, I mean, we would need here type of whatever, proc bits or which one is it? Properties. Type section. Section type is age type. I would expect type section, no type section function. Is this even the right type? Appear below as age type. So now this type is just section. The section operation defined by the program whose format and meaning are determined. Program. Okay, whatever. Is this all in the section? We would need section header name. So sh name, section header name. And we would need an elf string in our section header string tab. Which probably would be like 1. And set string tab. So we need. Or did I even? Here are the types. Look at this properties. Properties. After all, I was looking into the wrong. Which table was it? I was looking into the wrong table for some. Symbol table. That is why I was wondering. It doesn't make sense. Here are properties. I thought it's properties. So offset align. So what we do need, what do we have here? Size. So that's 0. That is, which one did we even want to write? We wanted to write the section header for the string tabs here. Basically we need, okay, this is string tab. Look here, the string could, no, it's symbol tab and string tab could not be recycled. Size of, okay, section header here in bytes. And where was this? Start of section headers. Where is string tab? Right. Okay. So so this only needs the start of the section headers. And the section headers has a string tab. So so first any program would need to read the section headers to determine the string tab to print. Not sure if I like this the most, but it is what it is. So section header, so we would have string tab, type string tab. What is this type number? I think this document did this had numbers for? No, it didn't. Section header, string tab. Not nice that they don't specify the values there. Section header, string tab. We need some there. Node bits. Well. Some GNU high low user. Not amused. So many. Number of defined types. I did this already. Lucky us. Then section header, SHT, string type. Okay, we would need right section header. Okay, this would need, so in F we need section header. Wait, the first had to be null, right? Nearly deleted that. Had this here already. And so because here we generate strings, we need those to return the offset at least for, or we save one. Where is okay, let's see if this has any chance to work. String tab. Let's maybe have at least the string tab generate today. Symbol tab, where is... Okay, so it's probably not even printing that. That is the offset, right? That is probably the offset into the raw file, right? From the beginning. Where is offset? Probably beginning of the file, everything. Usually it's beginning from the file or after the header. Must members value gives the byte offset from the beginning of the file to the first byte of the section. So which section did we wanna yeah, so some things to write here are really a little bit, I mean, we could generate, I mean, maybe we need to generate them in memory and then write them, because if we write that here, we don't have the offset of the string tab, you all. Here to do. What else do we need? We type, name, type, offset, and all the other stuff that are size. Yeah, there are quite some things to do. What else do we address? Section memory element, otherwise the member. Okay, maybe 0. Size gives the section size, and the section has no width. Section occupies the file. Time must no space in the file. The sections size and byte. So probably. Actually, we can generate, we don't need to write that immediately. Actually, we could, actually it is easy, as this is only the maintenance information. We could, what was that here? Section, how did I had to erase some section, or is, did I YOLO together here? Section writes, it just writes the raw thing here. So if we generate all this stuff, look, so what else do we need? So, I mean, we need to generate, basically before we call this, we generate the code, we generate the symbols. So that's assembler, right? Like we are still writing assembler and linker, like basically everything from scratch. Ironically, if we just JIT this in memory, we don't need of this. Like basically my idea of like, let's be able to test interoperability, and that, which we would want. Basically, given if we want that this language becomes popular, obviously we need interoperability with other things like other C and C++ things or Rust. So we basically need ELF on most platforms. So I guess it's a good, as annoying as it is to implement all the structures. Yeah, it is what it is. Because in memory would be easier. Like basically just generate some function, like allocate some read-writable executable page. Or like if write not execute, then JIT it and remap it non-writable for security reasons. JIT the code in there and we're done. And basically, people always like, JIT so complicated. It's like, yeah, actually, interoperability and like standard. That's actually pretty complicated. Yeah, if we generate this first, like basically, do we need? So basically, if we would write code, like basically, so what would we need to do? Like basically, many sections we have the info, but do you really want to implement all this stuff up front? Well, we need it earlier, right? Like sure, we could first do. I mean, you could output to C or assembler, and so I don't want to output to C. Like basically, this code that we need, like if we output to C or assembler, that's code we later don't need. And get going with the, yeah. So that is kind of true. I mean, at least 74 people tune in. That's not that bad. We need to grow an audience. We need to grow an audience to finance our language. So to C is pointless because that is what I will never use in production, right? Like basically, at least this stuff. I mean, sure, we later need to rewrite and refactor, but for me, of course, I knew ELF. I've worked with this ELF stuff for 25 years, but I never rewritten this stuff from, like, I constantly look into stuff, but it's one thing of like, 25% of the general ELF data structures, and like you need to know all the details to actually write this right. We still learn a lot, and this is all the knowledge that hopefully mostly accumulates in my brain. At least this stuff we mostly need, or probably definitely need if we wanted. There are two things, like either we do a nice language and the JITs and stuff and doesn't need to have any interoperability with other compilers and linkers, then we wouldn't need that. But given that we plan a full first-class, full-featured language, we would need this ELF stuff, right? So that's not as bad as if we write code to generate C code, then that would be stuff we wouldn't use. I want this stuff fast, right? Like to use vintage and retro systems. So like basically the idea is like how fast can we get this like Lua, and if we run GCC and Clang, it's slow again. I hope this wouldn't be. I mean, if I would sit here, like I probably could get it working in a day or day or two, or like basically in a weekend. So the idea is I want to reuse as little as possible. I specifically don't want to use all this 100 megabytes or 500 gigabyte of LV and Clang. If you go for JIT, most likely you would have some bytecode representation anyway. Not necessarily. So for JIT, we don't need bytecode for JIT, except the internal. Like so for JIT, we would parse it. We built some trees. We later optimize it. But so we have some in-memory tree structure, and we wouldn't need to generate bytecode from this. We could directly. I would directly. So basically, bytecode is just one additional layer. although we could use it as, we could wire it out as bytecode, because like what I would generate like natively, like if we generate this code tree structure of like load z, multiply with z and stuff, like some single static assignment as tree of things. We don't need bytecode. We can directly, like for each tree, like load stuff, then like generate our internal like load.8 for stuff, or if we load structures, by the way, not everything will be load.8, load.16. It might actually be copy a whole structure. Like if you, like some elf header structure equals some other thing, it actually needs to mem copy. But that is another thing. The cost, it's cool to see elf a bit more detailed. Never looked at that. Yeah. I mean, I looked at that. I never implemented it from scratch. Yeah. So yeah, we don't need bytecode. However, just some ideas to bootstrap links first. Yeah, so for our language, we need, I would want our code gen. I mean, you're right, we could generate that to C, but that would be kind of ugly and also pretty. I would rather get, I would say the beauty and most important thing is what we basically do is what Chris Lattner has done 20 years ago, starting LVM. Like, hey, people like, why do you do this stuff? I'm sure all the GNU people told Chris Lattner at University of somewhere, like, why do you do all this stuff? We have all the GNU stuff, right? Basically, we redo this now with the focus. Like, obviously, when Chris Lattner started, probably Chris Lattner, I'm pretty sure he had the same idea of like, let's make some tiny readable thing from scratch. And then 20 years later, every company has dumped their, like Apple, Google, Nvidia, AMD, Intel, ARM and stuff, and everywhere, obviously, MIPS, every Nintendo, Sony, everyone dumped their stuff in there. And sure, there is code review, there is like, nah, do it so, like, but at the end of the day, it's totally huge. I'm aware it could happen to us, but I would still hope, like, basically my project goal is different. The LVM project goal over the years became support everything. My project, my mission here, which I actually should spell out more clearly on the temporary placeholder website, keep stuff really stupid simple. And for that, I would say what I wanted to say is the core innovative thing is actually to have readable, and not like TCC, but readable. I should show you that. TCC git tiny C compiler. Why do I not use stuff like tiny C compiler? Because is it even the right thing here? It looks so fancy. Can that even be the real? Do they have a new non-official? That explains the thing. You know what? When Google gives you like the T2 project website, probably the better go-to thing here of that. Basically, I want TCC. I want basically a mix of Lua JIT-like, but better language, a better, more full-featured language than Lua, with tiny, like Lua JIT in Lua JIT plus, or kinda, right, in not Lua terms. Although Lua JIT has some CFFI. So the problem with TCC, I would love to reuse other people's code, but the problem is this code is simply not good, right? Also, I mean, you see, the code is probably not good because they don't, like, they can't even do releases anymore, which is hilarious. And the problem is also, the last time I checked here, I mean, and that's also the thing, probably, I mean, a huge compiler project is difficult, and it's like, yeah, okay, 12 days ago, but hey, they don't even commit daily. Sure, it's a tiny little hobby, like, that's the last, like, why can you, like, what is so challenging to put out one release a year? Like, I already know that this project, sure, it's a hobby project, they do it for fun, and they have no profit and stuff, but it should also not be how it is. Also, they have only code gen for very few languages. The problem here with this thing here is also, like, where's even tree here or here? It's C. Like, first of all, I want stuff highly stable, and that is why we bootstrap in C. Why we bootstrap in Lua. And the problem is also that their code gen is, like, it's extremely hard coded here. Also, maybe they cleaned it up already. So it's basically, that's exactly what I not want. Like, if this, then that magic number, and like, you see, yeah, sure. My thing here is also like, nah, whatever. So I would not find this here maintainable. Like, first, it's like, it might be, but this is also like why maybe they can't support more features, get it more stable. Of course, x86 being a whole bitch and highly overly complicated, sure. I've seen the RISC-V backend here, but they don't even have RISC-V32, right? They have code gen for what? For 4 architectures. ARM. Do they even have MIPS? I would like my stuff to be so portable and nicely structured and uniform that we can add with some pre-knowledge, and like, my dream would be to have this so simple structured that here's ARM. Okay, they have 5 maybe, so they have 32-bit ARM, 64-bit ARM. It's like everything in one file, like not like targets, like every. So they don't have PowerPC, they don't have Spark, I believe at least. They don't have, yeah. And like, they make extremely little progress, which might be because it's written like this. What is even here? ON, like, what the fuck is that even? Test bits of opcodes of, are you freaking? It's like, whatever. Like, basically that is why I cannot reuse it. Like this is obfuscated content stuff, yes, but I appreciate the effort and stuff, but I want this more readable. And so we need to have some freestanding stuff that we can. Bootstrapping in Lua is fine. In our hacked version of Lua with more nicely named things, in my opinion. Let instead of local, fn instead of function, and already makes a huge difference, in my opinion. And like normal comments, and like not dash comments. Sure, I use dash comment, and I used it for 15 years, but there is a limit. Yeah, so basically get more of our stuff working that we can migrate to our own stuff and rewrite this even more readable. And so the innovation is in this more readable code gen. Actually, and so you are right. Written, why it hasn't. I'm sure the way it's written contributed to the way. Yeah, totally. I think mostly it just doesn't have. I mean, the real use case would be a tiny C compiler, but maybe it should have been written a little bit more readable. Although, to be fair, Fabrice Bellard started it as a obfuscated C compiler. Like, maybe, right? I mean, as per usual with Fabrice Bellard's things, amazing project, amazing achievement, but I mean, sure, he moved on because it was one obfuscated tiny, the world's tiniest self-hosting amazing achievement, but maybe not the. I mean, sure, other people like, hey, let's make it more readable. They got somewhere. I mean, for what it is amazing. I think, but it also, like, if you have a hobby project, what I don't understand, they put time in there. Maybe they find it readable, but what the main thing, what I really don't understand, why can they not put at least one release out there, even if it's slightly buggy? It surely is better than 7 years ago. Like, yeah, release often, like at least once a year, like maybe once a quarter. I'm not even saying every, like maybe once we probably would all agree releasing once a year, or in between when there is some major fix, like major security fix, major bug fix, major feature things. Can't be that difficult. Anyway, I mean, there were some cool things, right? Like booting the Linux kernel in it, or I mean, I also would want a alternative tiny C compiler, just not in this code quality. And but anyway, so good. Sections. It's getting out of hand. So we said, okay, we need to write the stuff like to do, write text, okay, text, what was the other, was it data? Okay, I had this actually already. That was very clever. Would probably help if we prefix this with to do. So write the sections. Maybe we call the sections. What did I do here? String top. Nah, not sure if I should spell string out. But then we would accumulate the data. So we have our we soon have our code. Actually, we could write this out already. Is that purely? Do we have can this somehow read as like dash a is all, right? Like, can it more than a? It can't do, right? It's not dumping the code section, is it? I mean, okay, so the size is 4. I mean, so it's probably at most padded by alignment with zeros. Yeah, so the size is 8 and the alignment is whatever. So that is a pure code because we only have 2 instructions. So basically, I mean, as alignment aside and stuff, basically I would say it looks like we could just write the data, right? Like, what is in our, what do we have here in, that's not yet a string. We still need to, how did we, I forgot how do we store our code currently? As integer numbers? I think we stored as integer numbers, huh? Which is not ideal. Okay, we store it as integer numbers. That is not ideal. What do we have here? Test elf writing. Yeah, using Lua for this whole is holding us up a little bit in places. We need to be a little bit careful how we concatenate stuff together. There are a ton of C compilers that are also cool, but I mean, all the others are also not that many. I'm sure there's PCC, Portable C, but like even the OpenBSD or like some BSD people use like PCC, Portable C, but I think they also transitioned off of this, right? Using C is okay. So the data we don't have yet. The code is a little bit near. Basically, we would need to convert that you all. So we had here our stream. T was text and S was symbols. What did we do with? We don't do anything with symbols yet, right? Oh no, we do. I add here, okay, I add here the test. Test is at offset 0. Starting to confuse me already. Yeah, pro tip, don't use one data vars except low temporary vars. Symbols, text. I mean, I would call it code, but it's usually called text, so program text. Why did I do O? Opcode. okay, whatever. Because we need to make this a binary. I mean, oops. Maybe we text symbols so that it's more natural, not sure. Also not important. Of course we need to change it here then. Oh, I had this here text. Actually. Later we need more. Just we're still prototyping here something. Does it still work? No. 433. What even was that? That was our string tab. So if we generate the section, okay, what I wanted to do that's where I just stopped here though. Okay, let's not write this here for a second. It's probably fine. We need to convert that. Okay, we could actually, you know what, let's call this here code, just like, yeah, it does not matter the most. Just so that we have here. So it's a little bit low tech now, but that is sufficient for a test. I think Trap talked about TCC, the tiny C code generator. TCC, tiny C compiler. Okay, code and then like concatenate. This is a little bit nano. So text concatenate that. So that sucks a little bit in newer. So this in our languages will be better. Plus we will do other things. Like at least Lua doesn't have this, but we will not patch this today. We will do this in our languages. This is why we need to type this a little bit shitty, of course. Now, let's recycle our U types here. We can just U32 here. So it's a tiny performance optimization to first concatenate here our U32 things of O. Oh wait, I don't even need this here like this. Otherwise, if we would have concatenated four things, that would anyway. Okay, so text, so general converts this here to text and write it here. Let's hope that works. Probably. Then we have a string with this binary data. That's a little bit low tech. So we later there would be more functions and they should be padded and aligned and stuff. But notification overload here. So write elf header, then basically add here a section. I guess we do it like sections. It's the standard Lua way. Actually, maybe I don't need, like, if section's empty, maybe I just do it like this, right? Sections. Of course, this is a little bit open coded, like it's a little bit written like Python scripting or stuff, like, hey, it's a Lua fork. But I would argue it's vastly more readable than C. Sure, some, again, structs would be nice, and writing these structs is annoying like this, but look at all the beauty of readability, like without any memory allocation management things of like just generating all these tables together. I would call this vastly more readable than doing this even in C or whatnot. And certainly can't crash and stuff, right? Is that not? And that is where I want to innovate from. I want to innovate, like, and my language will not be, the language probably will be similar secure like Rust, which basically is not secure because Rust unsafe all over the place. But we should make our language so that similar to Rust and Lua. Also, like, it would help if we could type sections. I should have just copied this, damn it, sections. This is my goal of readability and not crashing stuff. So write this, okay, right, to do, we know we do it for real. I guess, so we need the offset and the size, right? All right, where was the SH? Probably size or offset a size, yes. Look at that, size, offset, basically the current, what is, I think it is, don't do this daily. Maybe some offset var. Let's let offset or off, and then off equals fseek. I think it was 0 current in Lua. So we need to have the current file descriptor position there. Generate a string, store in the table. That's not string tab, but proc bits or so. Proc bits. Offset is offset. I mean, ironically, we don't even need to save it. So, to be honest, but also, like, why save it if we can simply new line? No, that's too much. Why save it when bam sh size equals, I mean, the only other thing, yeah, more helper, more writer helper, like could do this once in some write section thing, but size is so later better, but for now size text. And then write it out. Do we have what? F write text. Yeah, it needs some helpers, even less open coded for data and text data, BSS. So data we don't have. We probably need an empty one. Actually, this needs a name. The name is text, right? Also, I have a typo here. Else string. Didn't finish this. Dot text. And here we need string top. So what we solved is, because why I had to refactor this is, we can't just write it and have a new string, right? It's like we need to pre-store this to have the strings allocated in our string tables. String tab. Is it that right? String tab and symbol tab and h. Okay, section headers. Okay, Z and Z. String. For where do we need it? The string tabs here, by the way. we don't really need that yet, right? Let's for now only write, okay, that I have at the beginning now. Write elf, okay, it's not right. What did we wanted to write? No, I lost my thought. Alright, I didn't want to write it. I copied this because we need to store this in sections. That's what I wanted to do. Section name, string tab things, offset. Good question, there we write it, huh? And size, does it have we have this length thing there, so sh size equals section header string tab length. That's probably that, right? We start, okay. Do we have right string tab? Yes, we have. What have I? Ah, because we need to write the section headers. Okay, this we don't need. And okay, write it. Right. String tab f even that is still I think there still might be some references. What we, by the way, we need also an entry for yeah, totally agree. Have you looked into safety of ATS? Yes. Yeah, totally agree. You can write relatively good looking C, but the problem is that everyone is using their own C libraries. Complete incompatible, like yeah, shows and glib and stuff, but also it for 90, 80 that probably was okay, but like since the year 2000 we probably want something yeah, like C++, right? Which sure, all the backward compatibility, but still better than nothing. We still have the problem that we have here some references of PB cores. What else do we need? I mean, theoretically other string things. Maybe the way to go here is, because I said we have here other references, right? I think we delay that writing that. And do here, I think the size was like 64 or so. I think we f seek 64. Oh wait, I have here already some string type. Because we need to update section headers, string table index, number of size of section headers. Oh wait, is this not? Oh no, this, I think this was 64. Size of this header 64. Yes. We need a couple of things. Start off section headers. Section headers basically. We didn't write them here yet. Okay, so write those sections. Then elf header. What was the name of the thing? sh. Need a language. We need a better editor and an LSP for. What is the name? E. Offset E entry section header. That was entry. Entry point 0, start of, okay, start of section headers. sh of esh of esh of. I mean, open coding this is not the finest. We don't really need it that often, huh? Because here we write the section headers, and then it needs a string type thing, right? Source number section header. Somehow it needs that for some reason. Not really sure why. Would it not be able to scan that? And like, why does it need that? It needs to scan that anyway, doesn't it? Section header string table index. Why does it need that if it needs to iterate this anyway? Some kind of optimization, vintage optimization. Because then, so that is here, basically update or either here or here. Should we, do we want to do that? Elf header e section header offset. Now some code completion would have been handy. Entry size, section header, string index, section header. This is how many section headers? Number of section headers and offset. Okay, number of. Okay, we need to update that too. So sh num and sh string offset. Section header. I should have copied this. Not easy to remember such. Obviously, this later will be in 2 files. sh num, sh string index, sh string index. Was it sh num? Oh, damn it. Was there anything else we needed? Sh num section header numbers. number of sections, and the section header things will always be the last at hours. So this probably will not work, huh? Do I have here section header offset 4 as for I comma as in I pairs sections. Already start to forget which keyword using here. Right of section header as right. And then we need a seekable file descriptor, but that is the least of my worries right now. That's probably the default thing. Probably should, and then write the header. Let's see what that gives us, if anything. Seek invalid option 64. Wait, what? Bit argument, invalid option 64. Is it first? Is this really begins? Was it something like begin? But here I have 0. This is really, that's, yeah. Current things, does it really need? Okay, the other thing is optional. What did I do here for current? I did this wrong even. That should give the current position, right? Good that we open coded it all over the place. Which one was that one here? String tab. This is that where we write this? Yeah, that's not the supermost API, but it is what it is. So was it begin? Was it back? Or what? Maybe it was pos or set. Seek set. Set and set. Yeah, API name. I mean, it's okay. It's just okay. That does something. Do we have halfway decent stuff in there? String tag text things. Look, we have some. The question is, do we have all of it? I mean, we have a elf header. Probably not correct. Possibly correct header, non-zero section header offset, but no. Oh, that is start of section headers. That's probably not ideal. Let me just make it all. Somehow we write start of section headers wrong. Start of start ESH offset seek current ESH offset. I mean, you know what the cool thing in Lua is? We could, like, usually I have a helper. Is there a helper? Like, we can just for k comma v in pairs of our, like, look at this reflective self-debugging of header do print k comma v and done. Is that not amazing? So we have here, look at that beauty. sh string index 2, probably correct if that is so. Size flex sh offset 87, that's actually, so that is, what was the offset? A section at offset 87. I mean, I don't know if that, can that be unaligned? I mean, maybe until stuff doesn't work because alignment. 87 doesn't look that bad. So we probably write it somehow offset. It's probably right of section. So basically we need a 87 in there. Oh wait, this is in decimal, huh? What did I just say? 87? Section header offset 87, 100, wait. Oh no, 87 is, we need, because it's upstream do. Okay, then I need to type format. In my fork it's FMT since some months already. What did I just say? 87. It's a 57 hex. Okay, that's there. Maybe that is offset a little bit. Where should that be in? Section header, file header. So section header. Section header. Oh, that's elf. That's even only elf32. So you can only have 4 gigabyte sized objects. Is that not n? Wait, or is that? What did I do there? This document is probably of our stuff. We write this as UN here currently. And UN is U64. What do we have? There was 64 variant. To complement little Endian version 1 API type. There was this, I mean, this stuff is correct. Or is this stuff big Endian? Is this not local Endian? Is the header always, is the header always big Endian? I mean, we could text them. That size should be, should this not be visible in? Maybe the header is always big Endian and then the rest is local Endian. Hey, T2 GCC stuff. So we have here, would we recognize that in stuff 01? Set size should be it's a little bit, maybe not only that. Oh, okay, probably a header or whatnot. Did we so 832 in? Oh, we don't have history. Do we have history? Don't have history. Probably should use here some calculators and not retype. It's 340 hex. Oh, look at that. Wait, what is that here? This is 4003. No, that is Little Endian. Oh, do I write it Big Endian? I'm getting confused. Wait, what even? What did I even? Button is set here. Here's 57 2 times. Do we write this in? Or maybe I write. What do I write here? Yes, we need syntax highlighting soon. Section header of that. I mean, so that, how many were that? 16? 16, 16, 32 E entry ph of SH. Or maybe, did I have to have a typo in here? Like maybe 0, 8, 16, 24, 32, 40, 48. Means that is the right place, but this is 64 bits, so this should not be. Why is this repeating? Can only be. Look at this. It's also the same here, huh? Oh, maybe that is. Okay, there is something wrong with my U64 thing. So what could be possibly wrong here? I mean, it should be do I or. I wonder what bit size did I had. Need our own language. Maybe they are only guaranteed to be. Maybe my integers are only. Yeah, maybe they are only. Why did I do that? Probably my bit shifting stuff patch in Lua. I mean, maybe that was upstream. Maybe because at that time, yeah, probably that shifting stuff is efficient. Probably that was, yeah, so there's probably a bit shifting stuff in our Lua pitch. Basically, we can't write full 64-bit things now in this version of Lua. So that, of course, sucks. That is why I need my own language where stuff doesn't suck. I mean, we don't have full 64-bit integers anyway in this Lua thing because it's Lua 5.1 with numbers are doubles. And then we have only 56 or so, significant bit of integers and floating points. So let's old-fashionedly high, like low, comma, high. Basically, so it's probably, yeah, it's okay. That's wrong because it's truncating that. So it's, yeah, that's why it's replicated. It's because it's truncating that to int32 and then shifting and. Okay, low high equals, so low is I 1, 2, 3, 4, and high is currently 0. Basically, let's make our language. We need our language. Yeah, so this doesn't scale. Obviously, this will lead way too often into problems. High low, yeah, it's like so low. Yeah, basically, let's get our code gen working. Like how many months to self-hosting? So that is currently 0. That should probably take care of that for now as workaround. Let's hope we don't need high bits anytime soon. So that's better, 87. So, but warning, possibly corrupt, non-zero section header offset, but no section headers. Maybe some type is wrong there, whatnot. Okay, so that's 87 now. That's better. But has non-zero. Maybe this section is. Why is this 0 number? Okay, that shouldn't be 0. Do I have a typo in that? So that is E section header num and section string index. Section header. I think I have here E. Yeah, so duck typing, yeah, statically typed struct thing would have want there. Yes, I know, we are migrating, I know. So E section header. String index 2, section header string, so it's table index, and where is E section? Actually, I think this should have been E indent, actually, probably. I guess it should be right, not that changes for nothing, but it would make sense. Where is our E section? We do that there, we do that there. I guess it's string index. Okay. We probably want a dump function. We usually have such a dump function in unexpected. Yeah, comment. Yeah. That's when you Frankenstein lure. Reading extends past the end of reading extends past end of file for section headers. Number of section headers is probably C section string table. How is this? Is this offset? This member holds header. Okay, header size. Header size, section header is 1 entry. All entries. Do I write those in? Hex dump. Maybe write them. This, what was the other offset of? Section header, section header. Here. File offset in bytes. Okay, should be from the beginning of the file. 87, or is it? Okay, maybe we need more. Maybe our section headers are too empty. What other types do we have here? Name, type, flex, address, offset, size. Or maybe this is a self size. Maybe it needs probably the size of. Would it? Where are this here? Oh no, actually no, the size should be the size of the thing. So what we have here, text for example 8. What? Oh no, actually it starts with name. Proc bits. I think we did proc bits. Address 0. Offset. What offset from? Or is it offset from the beginning? Okay, do we have here? Do we have offset? Section header offset current. And the size looks about 4 inpers. Okay, let's dump this object. Beauty kv in O object O print kv. Expected dump. Yeah, not fun. Size 8, offset 64, type 1. Ain't looking too bad. Unless I was wondering if that is really correct, that the section header is it not dynamically sized for 64-bit offsets, or section header. Now look at that. I think the spec is, nah, I think they are all dynamically. I was already wondering when I implemented this. Maybe this spec has it written somewhere else. Section header. 4 here, look at that sh. This is an okay, name index 4, sh type 4, and then starts sh8, sh flex as un, n 4 times n. Link info, address and size, I copied this from the spec, so either spec near or they mentioned somewhere else some layout for does it have read elf? Oh, look at this, we have a section header. Can you believe? Good, we have section header. Null entry, procbit, string tab. Hey, that even works here, except that one here. That doesn't work for some reason. The other stuff. We make progress. What else do we need? We need a symbol tab. Hey, maybe we can link this theoretically only 4 hours in. I kind of thought I have a keyboard in. It's dangerous. Keyboard out of the server. Not to. No USB thing was so there is this string tab, but yeah, I mean 4 hours here, 4 hours there. At the end of the month, we will have a freaking assembling code gen thing here that we only need to port to our language. Then why is this string? Do I do here? sh name elf string sh string tab dot string. Why does it not work? Text works. Why does this one not work? Or does it? Here I think here it had a. Yeah, .sh. Why is this? I mean, maybe we should set a line sometimes, but YOLO. Symbol tick string tab. How many strings does it? It has here some more strings, probably for other things. So there's where's even symbol? We need to check the layout of maybe symbol tab is probably it's custom format again. So why is this not working? Why is this not working? The first works. Why does the second not work? Where would that start? Which type is it? Maybe we dump that. Do we dump that already? Size, type, name 1, name 6. It is also basically it's somewhere here, like so that is 0. So we are here 0. That's the first. Then we have here text. Unless it is okay. So that is 0. Then we add 1. Do we add there 1 too little? Maybe we return this one here. So 0, 1, 2, 3, 4, 5, 6. This would be 1 plus stringling. What do we do there? Maybe we need that plus 1. Maybe that is off by 1. Right, section, string. No, I do here plus 1. So we start with 1. We save the ling. We add the string length. Well, we see in the dump what do we have here? Name 6. 0, 1, 2, 3, 4, 5, 6. Yeah, this is actually pointing there. So it's 1. We return 1. 1, 2, 3, 4. Then we add stringling of that is 5. 1, 2, 3, 4, 5. We have 1 at 5, so 6 should be 7 or not. String tab. So it's 1, we return 1. Off by 1 problem. That's the string. We add it to the array. We cache the length. We add the length. So this text is 5. We should add 1, 2, 3, 4, 5. We should add 6. Should be at 7 or not? sh string tab. I don't understand that. Anyone sees it? Is string length includes the null byte? No, not in Lua. Not in Lua. Unless, I mean, you can add an explicit 0. That's why I add here +1. Print. The previous value was that. The string is that. The new value is string tab length. It shouldn't be that difficult. Wait, it is 1, 2, 3, 4, 5. I forgot to. I'm so stupid. I forgot to add the. Yeah, what I meant here is plus equal. Yeah. Okay. String tab. Okay, problem solved. That is why somehow. Yeah, that's you think you add then and like sometimes even Genius is like error correction of like I'm surely adding that. Like surely adding that. Look at that, now it works. Beauty. The only other thing now is symbol tab. Maybe we can link it later at midnight or so. Maybe we should commit this not to accidentally lose some, because that would be a pity of 380 editions. I mean, to be fair, it's mostly opcodes that I didn't fill out fully, but yeah. Okay, so symbol tab. Next thing. Symbol. Do we have a symbol tab? Symbol or no? Symbol table. Object symbol table has information, needed things. So that here, although I have the suspicion this is again n. Why is this listed here so shitty? Or is this document so does it predate? Nah. Symbol entry. So index object symbol strings which represents has no name. So what do we have here? Symbol table only holds information. So it's probably just a table of object symbol tables information. The index 0 both designates the first entry. Undefined symbol index. Content of the content of the initial entry was specified. Wonderful. st bind type info local. Yeah. So the first is just zeros. Wonderful. Where's bloody 60 fit? Like somehow we constantly miss the 64-bit definitions. Like this somehow sucks. Table thing. What was the bloody type? Elf them. Because it's F32 them. Okay, basically all. Wait, symbol table entry.
Too late, now you want an interview, but back in the day I was.
Yeah, the music. The music there on our matching new music website. Okay, symbols annoying. Who's surprised? Let's type in some symbols. Right. Fn right f symbol fs symbol things. Welcome everyone. Something of that sort. Yeah, basically how did I usually do that? Alright, just sticking the symbol in there. So we have st name. What copy and paste it? What do you mean with electron 32? Not really. What is that? So probably UN, U8, oops, what was UN? Then all ST, name, value, size, ST, info, other, and SH and X. Probably like this, right? So what is this half type? Type for 16. Wait, this is also wrong. These types here somehow suck. Okay, shit. Word address word, probably word is okay, word is also like this types also really from hell. Okay, U32 word. Okay, address surely must be UN. Name. Wait, did I skip here something? Value. Value. Okay, that is the UN. U32, U8, U8. Half is 16. What the there. Is it like this? What is that symbol index? Is that Every symbol table entry is defined in relation to some sections. This member holds a relevant section. Header table index as figure related text describes some section index. Indicates special meanings. Value depending on the absolute value in the trash etc. Sizes. Sizes, for example, data object size number. Hold zeros and all things. So we have all we want is wait, this is our symbol tab. Why? Okay, this is somehow our section text function global. We need section. Okay, so that is do we really need to stick an entry in there of like telling it that's our text section? This is probably, does it work like 1, 2, 3? We need to specify these tables here again. Why is this so overspecified? It has already the name here, but this is text. Why does it need? Needs somehow section entries. I mean, that's hopefully. I mean, sure, we can generate everything. Like once we have nice function for everything, then it's easy peasy. But so all I basically wanted was that here. Let's generate one entry and see how it goes. Can we directly write them? Is there a reason why we couldn't directly write them? So where do we need that in? Syntab. So we need dash syntab of text. Write sections, text, data, symbols. Section set here. Alright, we don't have the size yet, right? Okay, basically we need better helpers for that. Better housekeeping helpers. Doing this open coded manually is of course not long-term amazing. What was it here? Sim tab type sim tab something. Okay, it wants a 0. So this was 0, this was all zeros, right? Do I need any special for writing the first? I mean, if we write... Yeah. Okay, let's do one global. Like basically we... Yeah. This is why you have automate this with nice helper functions. Storing the offsets and stuff. Let offset offset equals f. But basically first prototyping and then we make it better. Okay, this is not text. So then offset, we saved that, and size is in bytes, right? So current minus offset. That makes it certainly nicer. And then later we need some other nicer helpers around that. For as in for I comma as in I pairs of symbols do and then write, what did I call this? Elf write symbol. Write elf symbol. Basically, I mean, theoretically first an empty one, so okay, this would work syntactic sugar, but first an entry one because they want, and then basically a function. So do we have STT function already? No. Or do we can STT? No. Copy and paste in this day and age. Rocket science. Yeah, later, much better enums. We don't have enums yet. So that's an STT function. I mean, later we need to pass in a proper symbol table, but for now we only have a function. So STT, where is it? Symbol types in, what is the name? ST type? No. Name, okay, value is 0. Okay, name we need to allocate in the symbol. Which even? So do we have? So we have a string. That's what you need a string tab for. Holy smokes! Symbol string, header string. That is st name. St name equals our symbol name. Then the st Wait, do I even do this? Wait, do I do this even correctly? Oh, I don't do this correctly. What is my... I think it's a hash table. No, this is wrong. For s, I in pairs. Name s, st. I hope that so address is relative to our code section. So st value is our index into that. What other nice things do we need? Okay, this size, or darn it, it's a bloody size. Many symbols have associated sizes. Yeah, that's the size of the function. That's inconvenient. Don't have those metadata yet. So offset size. No, we have a size. Name I 0 1. It's 1 based because st value and size st size. Info other holds index into object symbol string table which holds the character representations of volume. Has no name. Oh, that is the name of the R. It needs R. It needs R. It needs. Ah. Why do you program? Because we write a new language. Also, like, what would LSP help us? How do you like we write language first? We had like this language does not exist yet. Do you want? You are welcome to write an LSP and highlighting. So we need what does it need? So that needs the st name. Hold an index into the objects file symbol table, which holds the character representation. If the value is non-zero, it represents a string table index that gives the symbol name. Symbol table name. It's a little bit confusing, you all. No, this is a fork of Lua. This is a Lua made like we work on our own language. Like we want tiny readable code gen and stuff, which it's not yet readable because we write stuff completely from scratch now. Because have you seen 4 GB Rust compiler code like working on this? If I use here, the other day I used here C and Lua mode, but that totally messed up more than it helped me. Sorry. Also, like, why do it's not painting by, it's not coding by colors. This is somewhat confusing. So info, we have here info things, binding. So bind type info things from good manipulate those values. Number currently holds 0. Okay, 0. Every symbol table is defined in relation to some section. This member holds the relevant section header table index. Okay, that's the section header table index. Okay, that makes sense. So, the only problem is now we don't know that yet, huh? Damn it, so much circular st section header index. Some indicate special meanings. Is there like some st? It's a global, right? Like how is this marked here? Bind this is bind function global type bind visibility. So function global default. It's only things global. So stb bind type info type bind info. So we need function. Do we have this here already? stb function. We don't have global, huh? Symbol binding stb. Didn't copy that enough for copy reasons. All right, because probably. How was it shifted together? We need probably symbol types. Did they have here? Somewhere they had manipulate. Info symbols. I had this already. Just not this. Where did they symbol value? Where did they here bind type info? Info is bind plus so 4 shift 4 stb bind on type stb shift 4. So stb global. What was it even? Info type. So type bind 4 info. So stb global. Bind 4 function stt function, right? stt amazing. So st info or something, right? So name, what do we have here? St. Okay, wait, this is also okay, that is actually name is elf string for string tab as value size info global stuff. What else do we need? This table. Do we have here special meaning of? Did they not say some main special? I had here somewhere everything. ST index table is relation to S figure 17 and related text. Some section index figure 17. Figure 17. Where's 17? 17. Figure 17, 32-bit inlet texture. What? Maybe here, maybe special section. Did they not write? What's it? Is it a bug in the standard? Object files, header table. Let's locate file section header table. Section header special section indexes undefined. Common. Wait, special section indexes. Did we talk about? Wait, there were special sections. Various sections, whole programs, things. Ah, yes, 114. Where is what does this want to tell me? Section list below are used systems and have indicated type and attributes. What does it help me for? Yeah, exactly. But so that's not the we do something new. We don't do type lure. We want something eventually beautiful. Somehow we digressed here now. All I wanted was we still need here this ST section index. Every symbol is defined in relation to some section. This member holds a relevant section header table index. So this needs text or what? So this needs a reference to text. Did we let text section maybe save that? Does it want that in there? ST section index equals text section. The question is, I hope it wants the symbol relative to the member holds an index into the option symbol string table. I mean, here it should only be wait, symbol? That's what we're writing. Symbol string table. Okay, which probably that's what they mean with that, right? Sym tab. Do we write? Oh, I'm getting so confused. Where are our tables of tables? Symbol tab, string tab. I mean, it's probably that one, right? What else should it be? Do we write this? Right. Oh, there's also something wrong. We only need to write this once. Write this undefined thing, write all others, let's hope for the best. Oops. Too close, 472 in 473. Look, there's color. Index global is H415, 415. F, SH, I mean, it's SH, SH, SM, is it ST symbol? Section header, F symbol. Kinda sorta of like SH, SH. It's like section S, right? As index local as Neil of, where is it now? 415 3. Attempting to index local as a null value in 415. What did I do wrong now? Trace back from 470. That's here. Oh, here. It's indeed true. Length of is attempting at length of string tab in 443, 443. In code from 472 string. What is my string tab? My second string tab. Let's string tab. What did I do with that for that not to sh string tab Section, text section, sh. Ah, here, typo. Did something. The question is, does it read elf? Warning, symbol found indexing sh info value of 0. That's not ideal. Link field. Okay, we made it. Writing more stuff, we make it worse. Warning, link field 0 should index link field 0. Yeah, we are getting somewhere. It's not yet fully. So much to quickly linking a test function for, yeah, of course. The only good thing is I would think that if we have some infrastructure together, stuff should move faster. Not really sure what its problem is now. Using section 2 as invalid sh entries of 0. Section 2 sh entry size. Section 2, by the way, does it decode our symbol tab size sh entry size? Then probably so. Write the stuff. Section +1 symbol sh size. How is it? 0. We save that. sh size current minus offset. Link field 0 should index a string section. Maybe that's already, but it has 18 now. Where's the size? Okay, there's some link field that I wasn't aware of. Link. sh link. Members hold a section header table. This member holds a section header table index link whose interpretation depends on the section type. So we need symbol, special sections, link, and here sh link. The section header index of associated string table sh link sh one greater than the symbol table index of the latest finding. Okay, sh link. So this is becoming a little bit annoying that we often need references for tables that we've not yet written. We don't. I mean, we could register this. So next we need to rearrange this code here a little bit. So header, where did we have that? Yeah, it's surprising amount. The problem is all this. I mean, yeah, it's for complex problems, of course, you need complex references. Where's our header? Basically, what we want is better. Like basically, we can easily solve this problem. I thought I quickly writing some stuff 4 hours later. If we had some classes, so much to people like object-oriented programming, evil like no, like instantiate some classes like this sections and stuff and add stuff keep all the housekeeping and at the end write them out, problem solved, right? Just we didn't have this because we started to define all the things. So we have that here already, sh link in header sections. So the problem is we don't have the string table yet, right? That is really inconvenient. You all, what was it? SST link? SH link? SH section header SH link. Ah, that is also not here. That is right symbol tab. It is here in I mean, for now, for a quick hack, I could like symbol, like basically it will be 2. That's of course not how you do it. Link failed should index a string section. Warning 2, link failed 2. Ah, it's one more. It's, yeah, you see, that's why you don't hardcode it. Do we have here? Ah, here's link and flex string. Here is it. Now we have, look at that. We have, oh no, one entry is also wrong. It doesn't complain the most anymore. Make progress, you all. Local found at index sh info value of, wait, what? Local symbol. Okay, probably this has, it wants visibility. It wants here some what do we have? No type. Value size. The size is somehow. Which, okay, let's at least get this. What do we dump here? SH size offset. We need something is a little bit off as per usual. Either this is even wrong here. Do we have here U32? Shouldn't size be like maybe UN? Oops. Would this not make sense if size? So name is used. Where are the other sizes? Address offset size. Yeah, there UN. Maybe I got this stupid typing here. Oh, look at this. The only problem is, so what do we have here? Warning value. We want okay, 0 is correct. This should be size 8, so, and this should identify as test. What else do we have here? Index undefined 1. Default and stuff, local. Okay, that shouldn't be undefined. And somehow sh-inf. Warning local symbol 0 found at index greater equals symtabs sh-info value of what? Symtabs sh-info. Sh-info? Not quite sure what's that one, but this value shouldn't be 0. This should be 0. So value, that's correct. 0 no type local so that the first one is correct, except that this one's about some SHN found at index. Maybe this needs some sizing set more correctly. Okay, but why is the second thing that should be S, comma I. So S is a string, I is value, and why is that not? That should be what? Maybe I should disable other dumping. Ah, okay, this is our instructions. Okay, this 2 is somehow wrong. Code is where do we convert that? Later more proper. Basically for every jetted function or generated function. This will not solve that this is completely wrong. Why is this completely... what do we do have? Oops, what do we... 08, that's correct. Somehow we don't write this correctly. Right elf symbol things. I mean, it wrote 0 correctly, and okay, we output 0 and 8. That is... Why is right elf symbol st value st size? T value un st value un st size. Unless here's probably something off by a little. What was? Probably it's not terminating correctly. Name, what was maybe we check here what is the definition of, where do we have somewhere symbol? Elf symbol thing, where would which type would that be? Elf 64. That's already Did I hit the 64? Wait, why is that name? Like, are you fucking kidding? Oh no, this is, but does it mean this name is also wrong? Okay, that is 64, then everything moves, of course, already a little bit. 8 bytes off. Okay, somehow now the... Okay, that is better. That is... How is this still off? Ah, wait, I did this wrong. I read this again, right? Because I wrote... No, this is wrong. Oh, this is... These types are really annoyingly named. Sorry. Word... Wait, what? Oh, they are differently ordered? They ordered the... What? Why? Why is this name value size info name info? Are you freaking kidding me? Why would you freaking do that? 1, 2, 3, 4, 5, 6, 1, 2, like, why did they fucking reorder? Like, for, I mean, obviously for alignment reasons, but this is not even aligned. Or is it? Oh no, it is aligned. Name info, you can't make this up. Name info other? Oh bloody hell. Name info other. Name info other. That's also not fully aligned, huh? But it's index, that's why they have that here. Info other, that it's freaking aligned. Damn it. Maybe that's correct now. Screw more. Look at that, now it's correct. Amazing. Amazing, we're getting somewhere. Not really sure why it whines about symbol tubs sh info value of warning local symbol 0 found at index syntubs sh value of 0. Not 100% sure what this want to tell me. So does it whine even more? So hey, look at this. It only like 4.5 hours after work, and we preliminary generate some elf thing. Of course not yet pretty. And needs. I mean, the annoying thing is, I intuitively thought like all the fields are the same, just as addressings are 32, like, but they reordered them. That is, of course, I thought I make them members of, but that super sucks. Oh. I mean, good that we've seen this. Like, usually I only wanted to make Endianness helpers of like that thing as, or yeah, probably we just need 2 defines then for like 2 structs like they do, but this like the more curse things you do, it's like the more curse things you find. So is that here, by the way? So if we take a look what GCC generated, what do we have here for index 1? So numbers, that's 0 size 8, no type function, local global, default index. What was this index for? We have here index 2. Maybe that is why it's wanting founded index. Maybe it doesn't like this index. What is this index for? Index in. What was this index? Symbol. Symbol table entry 0. No, not index, not that index. index visibility type. What do we have there? Num value size type bind visibility. Value. I know I just reordered some stuff. Okay, the name is also and info other index. This should be the section, right? Section 2. What do they have? Section 1 text. That was a section. Probably isn't it? Is it a possibility? Section 8 for risk 5x. Yeah, this is a section number. Local symbol 0 found at index syntax sh info value of but this is also, this should be 1, right? This is also Lua versus, this is off by 1 for Lua versus just save it first. That is off by 1 for Lua's 1 versus 0 versus 1 based indexing. Okay, now it's only winding with only one warning here left. Very theoretically, I mean, the question is, what does I don't have. One life is disassembled. Text section of test mentioned in J but not found in input file. Here's text, so somehow it doesn't. Okay, somehow it doesn't like that. I need to debug that. Here's also error section 2 as an entry size of 0. Here's an unit sh end size. It's probably not ideal. Expected size of 18. sh end size. Also wrong. sh end size. Oh, I have them all 0. That's probably not good. There is S size and entry size. There are 2 sizes. What is entry size? Why does this reload? Because I pressed on it. Holds table, fixed size entry such as for such a section. This member gives the size of bytes of each entry. So consider if the section does not hold the table fixed size entries. Okay, entry size is normally we would size off the thing, but we don't have that. Which is like, yeah, we ASAP need. Yeah, we shouldn't do this all in Lua. Like basically bootstrap 1 in Lua, and like, yeah, we need to get rid of this Lua bootstrap ASAP. sh entry, is it the symbol or symbol? This one, symbol section things. Which one did I know? This is not a symbol. I mean, it says 18, right? We could just copy this. It said 18, it's probably 18. Did it say 18? Sh entry symbol here of. Oh, wait, it was a table, so that's sections symbol tab. We basically need to do both here. Sh and size 18. Would be really cool. I think we will not finish that. Like basically, what time do we even? Yeah, we will not finish this today. Still winds here of sh and size. Maybe I mistyped this. sh and size. Or did it complain about? I did redo this, right? Section 2, sh and size. Did I do this for the wrong section? No, this should. Unless it's also differently ordered and I write it to the wrong location again. Now that's the section header at the end, sh and size. Sh and size. UN? Is that really UN? Actually. We need to check the ordering here. Name type. This is so stupid that they changed the order of something. Size link. But it's the same. Entry size if section holds table. Sim tab. Not sure why this. Why does it say 12 SS invalid sh and size? Did I not just, or did I have a typo? Or is it another table now? Section 2 has zoom tab or not. Section 2 has a limited sh and size of 12. What? Where does it output that? Section 2? I mean, it should be this. I mean, okay, that's not in here. That is symbol table contains. Where does it? Section headers is. Oops, okay, this was the right thing here. Where is so size entries? So there's 18, but it probably corrected that, I guess. It's link 3. That's where I have link 3. Link 3 sh. It's bizarre. What do I do wrong here? Section header. That's unclear. Do I need to hex dump that already? The question is so... I mean, we could also dump here this section headers. If 18 there. 1. Is unless it's printing that in hex, because I think previously it is 12 versus maybe it's 18 hex. Pro tip diagnostics. Oops. I guess so. We should be close. I think that fixed it as this was hex versus. Yeah, pro tip prefix stuff with appropriate power of whatever. Yeah, I guess no, it doesn't complain. It's still one thing here of its local symbol 0 font at index sh info value of 0. I'm not sure what that should tell me. Why does it? Sh info value of... Is there some max? Not sure what. Maybe we are lucky and is this symbols? Oh, look at that. Hey, we have GNU elf stuff accepting our quickly in just 4 hours quirk. Yeah, there's our first, at least last 10 minutes well investigated. Of course, it's not totally feature complete, but I wonder if, okay, now we can't, I mean, if we test, it's like main C, if we test C is like so, if we do, if we like let's try to run that int main, also like nothing. Let's hope that works like this. Include standard IO. So that is doing what it's adding this or whatever. Right? What did we, I think we added that. So let's print if test. Might be our first code ever run with our own new from scratch JIT. Only needs the rest of the infrastructure. 1, 2. I guess that if we edit that, guess we edit that or whatnot. So oops. GCC, if we output, okay, you can also a.out. So we want main C and home. I guess we can do this in one step. Test O. Symtab symbol index. Okay, it's whining. It's also whining about that. Bad error adding symbols. Bad value. I mean, maybe it's some local symbol at sh info. This complains about the same thing. Okay, we are close. Can't link it just yet. Whatever. Yeah, diagnostics. I mean, sure, GNU developer and stuff. It works. I tested this. But I mean, bad value, which bad value now is maybe only this one, but I mean, we could also quickly. Yeah, but I need to go. Basically, need to go. Amazing that so many people tuned in. We also should commit this here to how many other changes do we have? Like, yeah, initially it's one symbol and stuff. I mean, theoretically, nothing stops us from actually generating more already, but obviously for more we need infrastructure. I would suggest we urgently, like I realize doing this in all Lua. I mean, we can do a lot in all Lua, but some limitations are certainly annoying. You can work around everything, but it just ain't pretty then anymore. So I guess like x86 is way too complex to generate. Not as nicely uniform as RISC-V. I guess we make RISC-V currently it's the latest and greatest hit and stuff. Basically, we will use RISC-V as our bootstrap platform because it's so open and we love it so much, and we have enough systems for that. And of course, that stuff will support cross-compiling and stuff. We need one halfway decently, mostly full-featured implementation. To get rid of our Lua base and have this much more nicely readable, like with enums and with structs, like normal. It's sure Lua minimal and not really the scope of Lua, but if we want to write really new readable and stuff, new great reset code from scratch, we need our code maximum readable, and that is currently not maximum readable. Yeah, commit early, commit often. I also need to publish this sometime soon. It's not yet the most, but hey, we are nearly there. In initial mostly working writer hack. Yeah, just some hours a day, and at the end of the month you have some code gen. I hope. Famous lost words. Maybe it's just this one thing. We will see. Maybe I will try later. Amazing that so many people watched. You know where all the other things, right? Otherwise, by the way, we do T2 Linux, and you can support us there, right? If you want to support this craziness. Next, in these days, as much as it pains me, we probably also need some nicely summarized website thing, right? I started some, although usually the good old-fashioned thing first do the stuff, then the website. But if you want to attract people, then these days probably first some nicely summarized, like attract more people early to accelerate the development. Yeah, have a good night, have a good day. I hope you enjoyed this, learned something. Let's find something nice to write, and see you next time.